Bismillahirrahmanirrahim. Mrs. Sobia Sohail is here with Assalamu alaikum, my dear students. Hopefully, you are doing well. Unit number 2, exercise 2.3, we were doing. In the previous parts, I have solved the question till question number 13. Almost all the parts with the different steps I have solved. This is the question which is little different with the as compared to the other questions. So, in these type of the question, mostly I suggest what you will do. Which one? No, whenever you have the radical expressions, so we are doing, yeah, exactly, rationalization. On rationalization, we have to keep that in the mind. Whenever we have the complicated radical expression, we should take the help with the rationalization to make it little simple. Okay, so we want to make the denominator simple, so we will do the rationalization with the denominator component. Okay, numerator will be kept as it is, denominator will be written first as it is, but we multiply and divide with the conjugate of the denominator. Conjugate called, write down these two terms as it is with the central sign change. Okay, first term as it is, second term as it is, only the middle sign change, and the same down also. Okay, what will happen? What is our main focus? That a plus b and a minus b form. So in the denominator, a square minus b square can be there. A square and minus b square can be formed. But what happened in the numerator? If we check same, same, sign same, it means that first term, second term exactly same. So whole square could be there. Whole square like a minus b whole square. We can write that as it is in the whole square form, so that we can apply the formula also. Okay. Now a minus b whole square. Apply the formula. A square plus b square minus 2 times a and b divided by. When I take square of this one part, what will be left? Yeah, square will be cancelled with the square root, 1 plus x there, minus 1 minus x there. Now again this one square cancel with the square root, 1 plus x, plus sign, so I am not putting bracket, 1 minus x, minus 2 times, and you know 1 plus x and 1 minus x will be changing to 1 minus x square under the same square root. Divided by 1 plus x minus 1 minus minus plus x. Now what is cancel? In the numerator x minus x plus 1 minus. Okay. Never cancel 2 minus 2, because this 2 is connected as a coefficient of this function. Okay. So 1 plus 1 2, 2 minus 2 square root of 1 minus x square divided by x plus x 2x. Still we cannot cancel them until we are taking 2 as a common. Okay, take 2 as a common, 1 minus x square left, and then over 2x. Now we can cancel. Okay, so this is left, 1 minus x square divided by x. This is the complete expression of y. I want to take derivative on the same step to avoid my wastage of time. Yes, derivative of this, apply the quotient rule, denominator square, then denominator as it is, derivative of numerator, good, minus numerator as it is, derivative of denominator, good. Can I write this 1 over x square here? Okay, this x as it is, derivative of this when we are doing constant derivative 0, minus its power rule will be applied, power in start 1 minus x square power 1 by 2 minus 1, and derivative of the function, derivative of function, that is 1 minus x square. Okay, what I do here, when I am taking derivative of this one function, its power is 1 by 2. 1 by 2 in the start, power 1 by 2 minus 1, and derivative of the function inside the power. Okay. Until here, the derivative of this is completed. Now enclose a bracket minus this function as it is 1 minus x square, and its derivative is 1. So make a complete square bracket. Okay. This is the whole this is the whole denominator which I kept at the start. X, what is happening inside? The 0 we can ignore. Okay. Minus 1 by 2, but this power function 1 minus x square function become power minus 1 by 2. Yeah. Derivative of the 0 minus 2x. Okay. Now x is multiplied to this whole. So x is multiplied to this factor only. Keep that in mind, that from here to here derivative is completed. So this is the x which is multiplied to this complete function. After this minus, the second function is there. Okay. Now the whole term is completed, which has this as a denominator, 1 over x square. When x is multiplied to this one, okay, 2 and 2 cancel, minus and minus become plus, x and x will become x square, and now only this term left which has power minus 1 by 2. Okay. Minus 1 minus x square. It's okay. Now I can write x square here, divided by both. X square and 1 minus x square power minus 1 by 2 divided by x square, and minus 1 minus of 1 minus x square divided by x square. It's okay. This x square cancel with this. 1 minus x square whole power minus 1 by 2. Minus. This will stay as it is because we cannot further solve it. Yes? Okay. Can I shift it down? 1 over 1 minus x square minus 1 minus under root 1 minus x square divided by x square. We can keep it in the same form also, or we can keep the LCM also. Any way we can solve. If we are taking the LCM, x square and this one can be there. Okay. This dividing by this is cancelled. So this will be multiplied up. Okay. Right. It's becoming the same portion. No need for this one. Either you can keep it over here or you can keep it over here also in the simple, or this one also step you can leave the answer till here until you have to you have asked to simplify more. So any answer you can select in the more simplified form. Okay, because derivation is done till here. So if the derivation is done till here, whether you want to transform into the different formation, that is okay. Otherwise you can complete your answer till here also. Okay. So finally, the next one, the question number 15. Yes, this is the most trickiest question in this exercise, and you have to be very careful in this exercise when you are solving this question, because it has only one variable separate, product rule as well as the quotient rule. Both are applied in the same question. Question number 15. Let y is equal to x times a plus x divided by a minus x, like this. So as we are applying the derivative on this one, I will say that make this as one function, a plus x over a minus x. Okay, I will use the big space in this question especially. First, a product rule. First term this I want to take because I want to keep first term as it is, derivative of this, because then this as it is, derivative of this, its derivative will go little longer. Okay, so first a plus x over a minus x, I want to keep it as it is, derivative of second function, plus x as it is, derivative of this function. Yeah, simultaneously you have to take the derivative of both. Okay, now this is solved because its derivative is 1. Yeah, so this will be as it is, plus This is as it is. Derivative of this will use the power rule. Whole power 1 by 2 in the start, power power minus 1, and derivative of the function without power. It's okay. Equal sign. This is single step. Be careful when you're writing the steps. Don't put the equal sign here. Equal sign is here. This is single step. Okay. So a plus x over a minus x going as it is, plus x by 2 and its power. Okay, let me write once in the same. 1 by 2 minus 1 minus 1 by 2. Derivative of this I'm writing here. Again it will apply the quotient rule. A minus x whole square, a minus x derivative of a plus x minus a plus x. I say you keep this same, and derivative of a minus x. Okay, again it is exactly the same step. Okay, I'm writing this over here now. A plus x over a minus x, same, plus x by 2, reciprocal of this making the power positive. So a minus x up, a plus x down, and the power will become 1 by 2. And now maybe its answer can be filled here. A minus x square, a minus x, and its derivative is 0 plus 0 plus 1. So 1 minus a plus x, and its derivative is 0 minus 1 means minus 1. It's okay. Now a plus x, a minus x, plus x by 2, a minus x, a plus x. Can I write in this form? A minus x square, a minus x minus a minus minus plus a plus x. This minus and minus multiply to give you this plus sign. Okay. Then a plus x over a minus x plus x by 2. Again I want to shift this power down because I can see this is a plus x. I can give it power separate and its power separate. So the base and base same. A minus x power 2, it will coming down, then its power will be minus 1 by 2. Okay. So a plus a 2a minus x plus x cancel. So this 2 and 2 also cancel. Okay, finally a plus x, I'm changing it like this. Yeah, plus x a divided by a plus x, its power left 3 by 2. Can I write 3 by 2 as power 1 by 2 and 1? Yes. Why I write like this one? I can take the LCM now because a minus 1, this power common. So LCM will write this also, common factor and uncommon factor also. So this will be the complete LCM. A plus x, a minus x, common factor, uncommon, uncommon, a minus x as it is. When this term factor is divided by this, a minus x, this cancel by this, remaining these two factor multiply out. Okay. So a plus x already present, this and this will multiply up, a plus x and a minus x. It's okay. Plus xa, because when this is divided by this, full will be cancelled. So nothing left, remainder which multiply up. Or making the denominator same, whatever the strategy you can use. Either if this is the LCM and if you want to make the denominator same, remaining element you can multiply and divide to make the denominator same. Now this a plus x means square, we'll change it a plus x. A minus x plus xa. Which one we can combine? Whether this one, a square minus x square under the same sign, a minus x. Okay. So shortly it become a square minus x square plus ax or xa a square minus x square square root and a minus x, it is completely solved. Thank you so much and Allah Hafiz until I will make the next part of the video. Hopefully you understand.